Okay, so the original title of this talk was how to bulletproof your system or how to bulletproof your database, but one of the main points I want to convey that you can never really bulletproof your cluster. So security is not something that you do one time in the design phase or in the installation phase. Rather, it's an ongoing process that needs to be iterated and iterated again and again. And the security work is never done. So don't consider anything bulletproof, and Scylla is included. So to gamify this talk and make it a little bit more fun, I created a security bingo. There are actually copies of the bingo with Guy there. You have a pack of bingos, you can pass it around. There is not enough for everyone, but I have something like 30 of those. And the first one who cover all this, I will cover all kinds of security measures that fix some of this security risk. And the first one who have a line or a row or column of mitigated security risk can call a bingo, and I will give him a Scylla puppet. So it's for those of you who have the bingo, you can try to play. I will cover some of the Scylla security features. You can see the list here. I can already tell you that the most important one are the two at the end. So it's you can stay here because that will be the most critical and interesting ones. So starting with authentication. So authentication, and this, by the way, is true for almost all the security measures that I will mention here, is disabled by default. Okay, so when you naively install a Scylla cluster according to the documentation, it's come with almost zero security feature enabled. And as a product manager, that's my responsibility and my fault, if you will. But we choose knowingly, and the same goes for other databases, to make the first installation or evaluation very easy, but it's also non-secured. So all of the security measures I'm going to mention here, you do need to enable them manually. Okay, and authentication included. Authentication is basically like any other authentication on your database or other system, forcing the user to authenticate itself with a login and a password. And once you do that, you can later activate authorization and define which user can do what. But the first phase of that is forcing the user to authenticate itself. Now, if you already have a running production cluster without authentication, it's not great, but you can fix it. The problem that if you just activate or enable authentication, all of your current application will just stop working because none of them is using authentication. So, of course, authentication is something that should enable in the driver and the database, but it's hard to do it exactly in the same time. So Scylla, following Apache Cassandra, have what is called traditional authenticator. So if you're starting with no authentication, you can enable this transitional authenticator. This gives you time to use or not use authentication from your driver. You can then go to your application, enable authentication on application on the driver one by one. And once you do that, you can go back to the Scylla cluster and move from a transitional authenticator to password authenticator in each of the nodes. Of course, each of these changes require you to do configuration change and then a rolling restart of all the nodes. But with this method, you can move from non-authenticated to authenticated without downtime. Okay, so it's a pretty important feature, but the best, of course, if you move into production, enable authentication from scratch, and that's true for other security measures. The next feature is the authorization. Scylla have, again, come by default with no authorization, but if you do want to move to authorization, move to Cassandra Authorizer, which enable the role-based access control. Role-based access control, I'm sure most of you are familiar with it from other databases or other systems. You can specify which user can do what on the system. So you can grant permission per role. You can grant permission to read. You can grant permission to write. Read from a specific table, write to a specific table, create other user, etc. And one thing I want to mention, this is actually something that was different in earlier version of both Cassandra and Scylla, and change in Cassandra and Scylla 3. These days, you have roles and you have users, where user is actually a subset of roles. Okay, that was different in the old days, but now you are basically only creating roles, and the user, as we will see in a second in an example, is actually just a role with a login. Okay, so you can create an hierarchy of roles and user will be included. So I won't go over all the details of this example. It's part of the documentation. In the documentation, we're given an example, an elaborate example of a gym with trainers and trainees and staff and admin. Each of them have slightly different permissions on different tables and can do different action on each of the tables. The way to create such role, for example, as you can see here, I'm creating a role of a customer. I'm granting some permission to customer. I'm creating a role of a trainer, granting some permission to the trainer. In this case, I'm granting it the permission of a customer. So already you can see here I have two roles, and I'm granting permission of one role to the other role. And next, I'm granting more permission to the trainer or more table, because in this case, or in this example, trainer can do more than someone just come to the gym. And this is what I wanted to show. When I'm creating a role with a login and a password, it's basically a user. So the term user is not used here, but this is what you can think about as a user. And we have two users here. One is a trainer, and one is a customer. So you can imagine how that I can create a complex or a simple hierarchy of roles, each with slightly different permission, and I can inherit the permission from a role to a role. I won't spend time on the formal syntax of how to create role and such, but you can find it in the documentation. And I'm sure you cannot read that, but that's a table of permissions, an object that you can either enable or disable the permission per object. An object is a key space, table, etc. So it's pretty similar to those of you familiar with Oracle or MySQL or this kind of database. The concept is similar. So moving to the next security feature, again, disabled by default in Scylla. Encryption. We have two types of encryptions in Scylla. One encryption is encryption on transit. Encryption on transit protects your data either between the client and the database or between the nodes of the database. Encryption-at-rest is encryption of the data on storage. So encryption, and I will touch each of them separately. One thing to remember, encryption at transit and all the features that I covered so far are available on Scylla open source. Encryption at rest only available on Scylla Enterprise. Okay, that's the only feature that is only enterprise only that I covered so far. So encryption at transit. So first, what are we protecting from? And that's related to the bingo that you might have. So if you are not using encryption at transit, someone might snoop into the wire and basically capture, either through Wireshark even on this kind of tool, capture the packet that you are sending from your application to the database. And this information, of course, might be sensitive. If your database is holding user information, then you must send this user information across the wire, and someone might pick it up. Even worse, someone might execute a man-in-the-middle attack and pretend to be the database or pretend to be the user and exchange messages. And encryption at rest try to prevent that. It's very similar for those who are familiar with the way that the browser encrypted data between the browser and the web server, which HTTPS, similar things happen here. You should enable it again. It's disabled by default. I already mentioned it like 6 times, so I have 4 more time to mention it. But you should enable it manually, both on the driver and on the database. And the driver, of course, is compatible with Cassandra. So if it's the same driver that you would use Apache Cassandra encryption, you can use with Scylla. Very similar encryption between the nodes. Since Scylla is a distributed database, everything that you send to one node is usually replicated to other nodes, and that includes sensitive user information. The format will be slightly different, but the principle is the same. It may include sensitive information. You can define encryption at transit either between all the nodes or just between data center or region or just between racks. On some cases, it makes sense because inside the region, all the IP are private and it's less exposed. Maybe between data center, you have to send it across between regions or over the public internet, and it's more sensitive there, and you might want to encrypt just that. I can already guess that some people will ask me after what is the performance hit of encryption, both on the wire and on rest, and I can tell you it's minimal. So it's between, for encryption at rest, between 5%, encryption on the wire even less than that. So if you're worried about enabling encryption all over the place because of performance, usually it's not a valid worry, let me put it this way. Of course, you should check it, but it's not as bad. So we cover encryption at transit. You enable it through a PEM file and such. I'm not going to go into the detail. It's well documented, and most of you probably familiar with it from other platforms. Encryption at rest. As I mentioned, it's a Scylla Enterprise only feature. Encryption, it's important to understand what encryption at rest protects you from, because at least in my mind, it's less critical than encryption at transit. Encryption at rest protects you from someone breaking into your data center, take your hard drive or take your computer, run away with it to his lab, open it, try to enable it, and try to read the information from there. So this is the main thing that encryption at rest protects you from. It's a valid concern, but if you, for example, run in an AWS, you are pretty much protected against that. Okay, it still protects you from maybe from a malicious AWS user or something like that, but I think it's less of a concern. Please note, and this is something that confuses many people, and it's not just for Scylla, for encryption at rest in general. It doesn't protect you from someone logging or SSHing into your machine and read the data from disk. It does give an extra layer of protection, but it doesn't give you a full protection, because if someone already in your machine, he can read the keys to the encryption from memory or from disk or whatever the key is saved, and potentially read the data from there and decrypt the data using this key. I'm not saying it's easy, especially if the key, as we'll see later, is stored in a different machine, but it still needs to be in the memory of the Scylla server. Otherwise, Scylla will not be able to read the information. So it doesn't give you full protection against that. So we support using OpenSSL. We support all kinds of algorithms, how to encrypt the data. And when you create a table, as we will see in a minute, you can choose which algorithm, what's the key length and such, like you have in other systems. You have two types of information you want to encrypt on the disk, on storage. One is the easiest, is the user information, is the SS table. For those of you who are not familiar with SS table, that's basically the way that Scylla stores the persistent information on disk. It starting from mem table, then flash to SS table. Most of your data at any time is probably in SS table. And this is what you encrypt with SS table encryption. There is also information which might be sensitive user information in other files on the disk. And it can be on the commit log, hinted handoff files, and batch log. All of those are basically temporary queues which hold user information, and usually not as much. It can have a lot of information or some information, but not as much as the SS table. And each of these components have slightly different definition of encryption. So for SS table, I will skip that in essence of time. This is how you encrypt SS table. You're just doing when you create a table as part of the schema, you specify what algorithm you want to use, what key you want to use, and the key provider. The key provider, I have a slide just on that, so I'm not going to spend time on it now. And once I do that, every new SS table written to disk will be encrypted. Now, this is an important thing you need to understand. Once I do that, or if I alter the table to use an encryption, only new SS table will be encrypted. Okay? And why is it important? It's important especially if I'm doing an altered table and, for example, either changing the key or enable or disable encryption. Existing SS table will not be rewritten or encrypted with a new key. Just new SS table. New SS table can come from two sources. One of them is mem table flash to SS table. What is the second? Compaction, right. So these are the two cases when you write new SS table. And each of these new SS table will be encrypted with the new key. Or you can actually disable encryption as well with the same command with alter table. So if you want to encrypt all of your information with the new key, you need to use a node tool, a facility called node tool upgrade SS table that will basically read all the SS table from disk and write them again with the new parameters. By the way, this is a general command. You can also use it to change all the compaction strategy on all table or something like that. But for encryption, it will write the information with a new encryption key. Another side effect of that if you are changing the key, and you should change the key from time to time, you cannot naively throw away the old key. You need to keep it available because some of your SS table might be with the old key.
What about materialized views?
It's the same thing. Materials view, internally, materials view is just stable in Scylla. It's nothing different. They have their own SS table, and it's exactly the same. Okay, I'm speeding things up here a little bit because I'm a little bit late here. Encryption of system level information, which is a hint at end of, and commit log and such. It's not something that you can specify through the schema. It is something you can specify through the Scylla YAML. So you write down in the Scylla YAML that you want to encrypt this part as well, and Scylla will do it for you. And now the provider. The provider is an interesting thing. So the provider is where do Scylla get the keys from? Or put it in another direction, where do Scylla keep the keys of the encryption? So the first version of Scylla Enterprise with encryption-at-rest, 2019.1.1, only have the local provider. Local provider means that the keys are stored on disk. Can be a different disk or the same disk, but they are stored on disk. So if someone log into your machine, very easy for him to read the key and just use it. In the upcoming version of Scylla, Scylla Enterprise 2019.1.3, will provide more providers. So one of them is a CMIP protocol. CMIP protocol is a standard protocol to exchange keys. So if you have a CMIP-compatible server on your organization, you can keep the keys there, and Scylla will read the keys from there over CMIP. For example, HashiCorp just added CMIP compatibility to Vault. And there are other products out there that support CMIP. AWS key management does not support CMIP yet. Unfortunately, I hope they will add it. But if not, we're probably going to add protocol to this key management at some point. Skipping some of the slides here. Moving to the next security measure that you can activate. Auditing. Auditing, again, only available on Scylla Enterprise. Very simple mechanism, just audit action that users are taking on the database. That's not really a security thing, in such that it doesn't prevent anything, but it will allow you to maybe to identify a misuse of a user of the data after. You can define audited the auditing result of the log to be written either to the local log or to a table. Whatever you use, the best practice is to pull this information frequently from the node either to a log collection facility or just pull through CQL the data from the table, because if a malicious intruder go into the machine, he might be able to change the log as well. The granularity of the auditing, you don't want, or no, maybe you won't. You can't audit everything. So if you enable auditing for all the queries and all the inserts and such, you will need a bigger database than what you already have just for auditing. So usually we'll just enable auditing for security-related operation, like grant permission, create a user, and such, or maybe schema changes, which are not as often. Mostly it's not recommended to activate auditing on everything, but you have some granularity on key space level and operation level, what exactly you want to audit. Okay, and the next two slides are the most important ones. So if you slept through this part of the session, try to wake up now. The most basic security feature you want to enable is just minimize your network exposure. That's the most basic and most efficient things. You want to make sure that external server that can connect to the database will only be able to do that over CQL, for example. You don't want to give SSH keys or something like that to everyone. If you can use private IP and not public IP, much better. And that's nothing here is specific to Scylla. Everything, everything from other system. And this is the diagram of all the ports used by Scylla. I think it's all of them, including the monitoring and manager. So the best practice, and by the way, we are doing the same on Scylla Cloud. We have a Scylla Cloud session later today. Everything that I mentioned here is we apply it ourselves for the clusters that we manage, and this is the most important one. So for example, we are using a port 7001 for connection between the nodes, for the interconnection between the nodes, exchange data between nodes. So no one else needs to have access to this port outside of Scylla nodes. Okay, so and you should validate it routinely. So if, for example, the monitoring server shouldn't have access to this port, your application shouldn't have access to this port, and the same goes for each other port. So, for example, the nodes does not need to have CQL access over 9042 between them. They are not using that. So the best will be to create a firewall rule, or if you're using AWS, it will be a security group, and define all of those parameters in a way that you are limited your access just to valid IP and valid ports. And by the way, it's on many systems, and I see that in the past you are doing it on installation, and after a month, 2 months, someone add a node, someone change configuration and such, and you are by mistake exposing IP or exposing ports. So I'm not going to recommend specific products or specific project, but there are tools out there to validate exposure. There are tools out there, of course, to manage configuration, and it's recommended to use those to control these kind of parameters. For Scylla Cloud, we'll have a full session on that, but the same go for Scylla Cloud. For when you launch a cluster on Scylla Cloud, you need to specify the range of IP that the cloud server are open to. Try to minimize it as much as possible. If you can use VPC peering and drop all public IP, even better. Okay, just by dropping the public IP of your cluster, you are already took a huge step in securing your cluster. I don't know if you guys are familiar with Shodan. Who is familiar with this cool site? No one? Well, you should. So you can visit this site. It's like a Google of security problems. So you can go to this site, write Scylla, Cassandra, MongoDB, or some kind of IoT name, a camera, and it will just show you all the exposed databases in the internet. And you'll be shocked and surprised to see how many of those are. So from time to time, I'm using it and I'm writing Cassandra or Scylla to see if someone exposes database. Always there is someone. If you use Mongo or something, it's well known that Mongo was a target of an attack that people connect and encrypt the data there and ask for ransom. And this is just because people expose the IP on the internet, usually without a need. So if you block the IP, of course, you need to use authentication, authorization, all of that. But just make sure your IP is not public on the web. If you write in your company name here and there is a result, it's sad. Just, but it's something that you probably should try from time to time. Scylla Cloud Security, this is some of the things that we are using when we manage data for our customers. So we are using AWS Key Management. We're trying to limit everything in VPCs, have a separate VPC per cluster, and all other measures, but we have a session on that later today. So I'm not going to spend too much time on it. And I'm going to conclude by that going back to my first statement, that security is never something that you're really done with, unfortunately. It's like the laundry. You have to every day or every few days, you have to go back to it and test it. The best will be to automate the tool that tests your security, do penetration testing, or make sure you are not exposed, and go back to it routinely. Otherwise, eventually you will forget something and you will expose yourself. So whenever you can, minimize your exposure, update your key from time to time, use two-factor authentication where you can, for example, on Scylla Cloud. And very important, the last one, apply available security feature. So we recommend updating the latest Scylla version every time it's go out, and that's also true for the OS. So every day or every few days, all kinds of security vulnerability are published. The bad guys are reading that and just try to use that to attack all kinds of systems. So keep your OS up to date. And the same goes for Scylla and every other third party that you are using. We are working to add more security features to Scylla, like LDAP integration. We are adding more security features to Scylla Manager, and more security features are coming. And that's basically it. Who completed his bingo? So you actually, so he was the first one. So well done, and thank you very much.